So today we'll be discussing pacemaker. So in the pacemaker, you will see in the machine there are various settings. So we'll discuss the setting one by one. So first setting is sensitivity. And what is this? This is the ability of the pacemaker to recognize or identify the intrinsic heart activity. It is measured in millivolt. So low millivolt setting means it is more sensitive. How? I will explain. For example, if you have set a MB setting of 0.5 millivolt, then every small waveforms will be detected as actual beat, and the pacemaker will inhibit itself. So there will be no beat, producing asystole or pause. Similarly, high MB setting is less sensitive. How? If you have set the sensitivity at 5 millivolt, then all the voltage below 5, that is 4, 3, 2, 1, will be ignored. And it may be that at 4 millivolt, the heart can produce a contraction, the LV can contract, but it is not inhibited by the pacemaker, because pacemaker will only inhibit when it is 5. So at 4 it gives a beat. The pacemaker gives a beat on top of the left ventricular contraction. So what will happen? There can be R on T phenomenon, producing ventricular fibrillation or ventricular tachycardia, right? So there are two things. One is called undersense. How to remember this? So pacemaker is blind, undersense. Blind means it is reacting to anything and everything. The same example, the ventricle beats at 5 millivolt and the sensitivity setting your pacemaker is 10 millivolt. So at 5 millivolt the pacemaker is not inhibited. It produces a beat. The ventricle also beat on itself. Beats, pacemaker provides spacing. So this will produce a R on T phenomenon, producing V-fib or V-tach that can lead to death. It is blind. And similarly, what is oversensing? It is paranoid. It is paranoid. Means it has gone crazy. Crazy means it is reacting to every small waves. For example, the Cautery is ongoing. Any noise, any artifact, the pacemaker sees it as actual voltage produced from the ventricle, and it actually thinks the heart can contract on itself while it cannot. So the pacemaker is inhibited. At the same time, the heart is not contracting, so producing asystole or pause that can cause cardiac arrest and death, right? So this is very important, sensitivity setting. Another setting we have, that is called the output. That is the current that the pacemaker sends to the heart to produce a contraction. It is measured in milliampere. So once the current is given to the heart has to capture it to produce a contraction. For example, the current goes here and there is no contraction, there is no P wave, there is no QRS complex, there is no P or no QRS complex, so there is no capture. This is called failure to capture. So the current has to be enough to produce a contraction. This is the current, there is a P wave, this is the current, there is a QRS complex, right? This is adequate capture, this is failure to capture, right? Then we have something called rate. This is also something we set in the pacemaker. The rate is very important because it maintains the cardiac output. So this rate maintains the cardiac output. Also, it provides what you call as demand pacing. What does that mean? If the heart is beating at 40, the pacemaker is set at 60, then this 20 beats will be provided by the pacemaker. This is called demand pacing. We need 60, you are getting 40, we need more 20, this being provided by the pacemaker. This is called demand pacing, right? So these are the basic settings in the pacemaker that I need to know to proceed in our discussion. Let us move forward. So now let us discuss nomenclature. We have heard things like DDD, VVI, VOO. What is that? There is a simple formula. This is called prostate specific antigen. P for pace, which chamber is being paced. S for sense, which chamber is being sensed. And what is the result? The action. Right? Example, VVI. So if you put PSA, ventricle is paced, ventricle is sensed, and the action is I. This is inhibition. What does that mean? When the ventricle is sensed that it can produce a voltage enough to produce a natural contraction, then it will inhibit the pacemaker to produce a paced beat, right? However, if the pacemaker do not sense the ventricle can produce on its own, then there is no inhibition and the ventricle is paced, there is a paced beat, right? For example, DDI. So the both atrium and ventricle are paced, both atrioventricle are sensed, and the action will be, it can both be inhibition and trigger. Trigger is less used nowadays, it's mostly historical, and inhibition is the primary function of the pacemakers, right? So this is how it is being nomenclature. Now there is a frequent thing you will heard while patient is going to OT. The cardiologist is being called, the pacemaker company is being called to change the settings before patient goes to ICU. Why that happens? Let us discuss. Because in the operation theatre we use electrocautery. So the electrocautery will produce electricity, and those electricity will produce electromagnetic interference, will send currents, and those currents will be taken as intrinsic activity of the heart. It can be P wave or R wave, and the pacemaker is inhibited, producing pause or asystole, leading to death. So that is the reason why before patient goes to the OT, the setting needs to be changed. And what to change? For example, if the patient is having VVI, we make it VOO. The ventricle is paced, but there is no sense, there is no response to sense, no inhibition. So this is called asynchronous mode. What does that mean? So there is no sense, there is no inhibition. So whatever be the current, whatever be the activity of the heart, it is immaterial. The pacemaker is going to pace the rate at which you have set. So there is no question of pause or asystole. So it is very, very important to change the setting from VVI to VOO. It's called OT mode. Or if the patient is in DDD, change it to DOO. No sense, no inhibition, only pacing. Right? So this is the reason Why? Before patient goes to OT, you have to ensure that the pacemaker mode has been changed to VOO or DOO, right? And same for magnets. If you put a magnet on a pacemaker, what will happen? The magnet will nullify, it will disable the sensing function. So it becomes same like VOO from VVI, DDD to DOO, right? These are called asynchronous mode. But these things are temporary. Once patient comes from the OT, it needs to be changed to initial setting. Otherwise, there will be catastrophe. How? Let us discuss. So this is intrinsic rate. This is pacemaker rate. This is mode, and this is result. We have four situations. In the first situation, the intrinsic rate of the heart is 80. The pacemaker rate is 50. The mode is DDD. Because the pacemaker rate is 50, the intrinsic rate is 80. So the intrinsic rate overrides the pacemaker rate and the resultant heart rate will be 80. Right? There will be no demand pacing. If the intrinsic rate of the heart is 50, the pacemaker rate is 80 and it is on DDD, then the pacemaker rate will override the intrinsic heart rate and the resultant rate will be 80. The intrinsic rate is 50 and the pacemaker rate is 80, but we have DOO, the OT mode. What will happen? It will only pace. There is no sense. So the pacemaker rate is 80, it is 50. So it will override the intrinsic rate. The rate will be 80. Now what happens? If the intrinsic rate is 80, pacemaker rate is 50, we have DOO. What will happen? Because the intrinsic rate is 80, the heart is beating at 80 and pacemaker rate is 50 and the pacemaker is not inhibited. So the pacemaker will also produce its own beat and heart will produce its own beat. So there will be collision producing R on T, producing VFib, producing VTAC. So as soon as the patient comes out of the ICU, you need to change to DOO to DD or VOO to VI, VVI. It's very, very important. In the OT also the same thing can happen. But there the risk we have taken against the benefit, right? But as soon as it is over, you need to change back. You need to change it back again, right? So there are different kinds of pacing. So 000 is turned off mode. Then there is single chamber pacing. There is single chamber pacing. This can be AAI or AOO. For this to function AI especially, the AV node has to be intact. Otherwise, there will be asynchrony. AO is the magnet mode or the OT mode, right? Similarly, there can be single chamber pacing with VVI and VOO, right? When the AV node is screwed, is not functioning well. So if you are pacing the atrium also, it will not come to the ventricle. So you need to pace the ventricle. So when the AV node is bad, you put the patient on VVI. But the problem is, so there is no synchrony between atrium and ventricle, right? And VO is the magnet mode. This is single chamber pacing. right? If the RV is paced, then there will be LBB pattern in the ECG. So if you find a ECG where there is LBBB, do not consider it as a new cardiac event. Just check if it is RV paced pacemaker. If LV is paced similarly, there will be RBB, right, in the ECG. So always check whenever you find these things. Always check whether there is a pacemaker in the patient or not. The best is the dual chamber mount. This is a single chamber, then we have dual chamber, usually used in complete heart block, right? This is hemodynamically superior. Definitely there is synchrony, there is good synchrony, and because of that there is improved cardiac output. It also prevent pacemaker syndrome. What is that? In single chamber pacing, what will happen? Some amount of electricity can go backward to the atrium and produce contraction at the same time as the ventricle, producing a resultant dysynchrony and decrease in cardiac output. That's called pacemaker syndrome. But in DDD, what will happen? Retrograde activation of the atrial contraction. There is very less chance. So there is less chance of developing a atrial contraction, atrial fibrillation in DDD mode. So it prevents the pacemaker syndrome. And there is another dual chamber, single chamber turnover mode. There is another called overdrive pacing. This is especially used in VT, and there is demand pacing. When the heart rate is less than the set ppm rate, the ppm will provide the additional rate. ppm will provide demand rate, extra rate, right? So this is how we classify, right? Now troubleshoot, we've already discussed. We'll just have a look at it. So undersensing, you decrease the sensitivity. Oversensing, you increase the sensitivity setting in the ventilator, right? Output failure, machine problem, mainly check connections, etc., right? Failure to capture, here the ICU team comes into existence. How to manage this failure to capture? Here we have to think about the reversible fact. Of course the current can be low, but we have to first check for the reversible things like potassium, acidosis, hypoxia, uh, drugs that can raise threshold, like your class 1C, 1B drugs, flecainide, etc., right? And also just do an X-ray and check for the lead position and increase milliampere current to see whether it can uh, now it can capture or not. Until that, in both these cases, we have to keep atropine ready. We have to keep external pacing ready, right? So this is normal PQRST, normal PQRST. Now the P is paced, so there is atrial pacing. So the PVB is there, but there is no ventricular pacing. So the AV node is intact. So it is producing a QRS. So here there is atrial pacing and normal AV conduction. So ventricular pacing is not required. Third, the PUAB is there, but after that QRS is not there. So here it is a spike. Then we have a QRS complex, right? So here ventricular pacing is there, with normal arterial activity. Here what is happening? Failure of AV conduction. And last, when failure of both atrium and AV conduction, then both will be paced. Atrium is paced, then ventricle is paced. So here, this is complete heart block. Both are paced. So always bipolar is preferred more than unipolar. Why? Because in the unipolar, what happens? The cautery tip and the ground, in between there is the body. So there is many pathway for the current to go to the ground. So there are too much of electrical magnetic interference, and this can affect the pacemaker. In bipolar, what happens? The current flows between the tip of the forceps only. So if it is a forceps, it is one tip, another tip, the current flows only here only. Unlike here, there are so many paths. This is one very small path. So there is very less electromagnetic interference, very teeny closed loop. So pacemaker is less affected, right? So if the patient is going to OT, you have to change the mode. You have to request the surgeon to use bipolar cautery. So this concludes our discussion on pacemaker.